Hello? Hello? Hello, I'm John O'Lardy, and this is my final presentation, I suppose, or demo for my augmented reality project. So my project was to do with the interacting with VR data, with MRI data in VR in hopefully a more naturalistic way than is allowed for on in traditional kind of flat screens. So I've chosen to make the project in Unity because it's got pretty good VR support. Although it's a bit finicky to set up. Once it's set up, it's pretty good, much like anything in Unity. I've also made use of this package here, so we can see this volume rendering tab that isn't normally there on Unity. Lets me load in some data sets in according to like specific formats, as well as uh, get cross sections and all these sorts of things we can do. So I have in my scene a, uh, a MRI scan of a brain, obviously being while they're listening to just to spoken word, and it's supposed to be used for testing. I think it's semantic language semantics decoding. Doesn't really matter um, for our purposes. So how this library functions is it uses ray marching, which is a technique described more in the report than this video. Pretty much to get into. But this lets us have transfer functions. So we can see here that this lets me. So basically, MRI is a map of density across the brain, and this lets me filter out specific. I can assign specific colors to specific densities. Um, so if I see these big spikes here, that's mostly just the other bits of the brain or the skull. So we don't really want them. We kind of just want the brain because it's more interesting than the skull. And yeah, so it lets us do all that. So I'm going to load up into VR. I have a Quest 2 headset that I've been using for development. So I've actually been able to test this in VR, and hopefully you'll be able to see what I see. I have hands and everything set up, and I'll demo that when I get into it. If it works. Just loading in now on my end. Yeah. Oh, jeez, I need to stand up. So hopefully you can see that. Yep, looks like you can. So yeah, you can see here. Well, I still have the Oculus pointers on. I don't know how that happened. So I'm in the VR environment. I've deliberately kept it really simple to just kind of show off this effect as opposed to other effects that, like I could make a nice little lab environment or something in VR, and that would really help with presence. But I think kind of the point of the project was to show this interaction, not not necessarily to do anything with the immersion. So I've implemented some stuff like continuous movement. It's in head direction as opposed to controller direction, as well as snap turning. Uh, there's also teleportation movement available and continuous turning, but these are just the settings I have on because I find them the most comfortable. So here we can see the brain scan. Well, the little table doesn't let me get too close. Um, we have our transfer function, so we can see bits of it. Can't grab it. Oh, so yeah, I also have these hands. These aren't by default. I got these off the internet. They're credited in the paper and probably in the description. But they're cool. They got a look nice animated between. So how it basically works is how an MRI scan tends to work is you take scans at different slices, and you can rotate the slices and all that. But it's a bit hard to do to rotate in 3 axes in a flat screen with a mouse. Whereas if I grab this plane and I start moving it through the brain, you can see over there that we get we can have our 6 degrees of freedom on the plane, and we can view the brain from any angle. And if I let go of it, it stays right where it was. It doesn't just fly off into space. So it's only interactable by grabbing. And you can get some interesting bits. You can see the kind of You can see the main structure of the brain there, but the eyes are up here, I think. I don't know. Anyways, so you can see some interesting bits and bobs, and it's kind of a more naturalistic technique for interacting with the MRI data than like was previously possible, or not possible. I'm sure someone's done something similar to this before, but you know that is typically done in clinical settings. Which is also pretty fun to just play around with. But I think that's pretty much it for the demo. Um, yeah, let me call it there. Bye. This is all wave this way. Bye.